My name is Vladimir, and I'm going to present the topic of geotagging of images and videos. Basically, I'll give you the general overview over this field. I'll present what the geotagging is, how visual and non-visual features can be used, how can they be combined, and what the future work, some directions for that future work. So, as we all know, the multimedia that is available on the internet is already enormous, and it's getting larger and larger every day. And a huge part of that multimedia are actually images and videos. Therefore, we have a lot of photo sharing services like Flickr or Panorama or Instagram, and they attract millions of people to upload their photos, to also look at other people's photos or comment. And therefore, we have a problem with organizing those huge collections, and we have a problem when we want to find certain image. One solution for this can be, if we have the geographical information about each photo and video, then we can organize them by geographical location. We can also search them by the location. And also having that information can open new possibilities in some new applications. For example, we can make the 3D scene reconstruction if we use the images from some landmarks. We can do the visualization of travel routes. That's, I think, interesting for tourists mostly. Or based on some previous uploads, we can make a user model and see what where some people like to travel, and then we can recommend them some similar places where they can also go. So first I would like to define what the geotagging actually is. Geotagging, that is the process of assigning geographical metadata to various media. Usually it consists of the geographical latitude and longitude, but it can also have some other information as well. And when I say various media, that can be images, videos that I'm going to talk about today. It can also be QR codes, websites, news can also be geotagged, so we can search by location. So how can we do the geotagging? I will talk here about the geotagging of images and videos in particular. Basically, we have three ways. One way is to have the GPS module directly connected to the camera, so when we take the image or video, it automatically embeds the geographical information details. But the problem is that a lot of cameras do not have that option now, and there are already millions of photos available that do not have that information. Second way to do it is by manually inputting the coordinates. For example, Flickr offers that to users. When they upload a photo, they can just click on a map and assign the photo to a certain location, but doing manually this for the huge collections, it's really not practical. That's why today I'll be focused on softwares that do automatic geotagging. The idea of those softwares is that we give them our test image or video, and they use some visual or non-visual features from those media, and based on that they make a decision about, or make the estimation of the location where the image or video was taken. I will first focus on how can we use the visual features, because visual features are the most natural for humans. When we look at a photo, just based on the visual analysis, we can extract already a lot of information. And the good thing about visual features are they always exist, unlike the non-visual features which we can have or not have. I'll talk about them later. But the problem is they're quite difficult for computational analysis. It's very difficult to extract information from just based on visual features from the images. And our final goal would be to make the semantic reasoning of images and videos, but still we're not even close to that with our current techniques. So I'll just show an example how can we use the visual features. For example, if we have this image of Eiffel Tower, that is a famous landmark, and in our database we have various images of other landmarks. We can do the pattern matching of our test image with database images, and we'll probably get some of these like the result. We can do this only for landmarks because of two reasons. First is it's quite easy to find photos from various angles, and therefore we can do the pattern matching. And the second reason is that the landmarks usually have some specific shape or color, something that makes them different from other places around the world. But if, for example, we have some landscape, for example a beach, and we want to do the same thing, we want to do the pattern matching and compare it to our database, this is quite difficult. First, to do the pattern matching for the whole world is not practical. We need to have the huge database of all the places around the world. And also, a lot of places around the world look alike. So we might have a match even though some places are in the different parts of the world. So this is not really the solution. Instead, we can represent the image using the low-level features. Low-level features can be like color histogram, line features, edge histogram, or something else. There are really a lot of low-level features that can be used. And therefore, we can just compare those low-level features of our test image to images in database. And the results show that we are able to identify the region of the world using this technique. But since, as I mentioned, there are a lot of regions that even in the world that look alike, we can do one thing. We can make the characteristics map of the world. And using these low-level features, we can recognize if there's a desert or there's a forest or snow in the image. And based on that, we can look at the characteristics map and we know where we can expect those features in the world. So if the software has to make a guess, it will be at least an educated guess. He won't miss completely, put a desert in Scandinavia or something like that. We can also use visual features to analyze videos, because videos, they consist of video frames that are actually just images, but it's not practical to take every frame and analyze it. So the problem with videos is that we need to choose the keyframes that we are going to analyze, and we can do that in two ways. One way is at fixed interval. For example, we take a frame at every 3 or 5 seconds. And the other option is to use some statistics, so we can see when some features change, and for example, where there's some abrupt change into certain feature, we take those frames as our keyframes. And since we have more than one frame that we analyzed, and for the whole video we need just single location as the answer, we need to make that one decision, and there are two ways. We can do the consensus voting, where each keyframe has the same effect on the final decision, or we can do the weighted voting, where each frame has a certain weight, and that weight depends on how much we are sure that the image comes from a certain location. I think the weighted voting is much better, but it's also more difficult to make it work properly. Also, interesting thing about videos are the videos from the static cameras, and they provide us with the temporal and visual features together, and when we combine those features, we can determine the sun trajectory. Even though if the sun is not visible in the scene, it's possible based on the shadows, there are algorithms that can calculate the sun trajectory, and they're very precise in determining the location of those static cameras. And so since we already have a lot of static web cameras around the world, if we know their location, we can, for example, construct weather maps or make the prediction of the satellite images. Next, I'm going to talk about the non-visual features. Basically, I'll talk about these three, and first I will focus on the textual metadata. Textual metadata is used a lot. A lot of papers focus on that metadata, and mostly they use only user-contributed metadata like tags, title, and description of images and videos, but it can also use comments from other people to extract more information from there. And we have three approaches to analysis of the text. So the first approach is to extract toponyms from the text, and then we use the external knowledge databases to see if those toponyms have geographical meaning, and if they do, we can find their exact coordinates. But one problem with this is that a lot of places around the world have the same name, and also there are places that have the same spelling as some words in other languages, so there can be a mix-up. The other approach is to use language models. Language model takes this location estimation problem as a classification problem, because it divides the world into areas. It builds a language model for each area based on the training set that we have. And then when we have a test image per video, we just classify it into the area where it's most likely to be, where there's the largest similarity between the language model and our test image. But the problem is that for the result we get the whole area. We don't get the precise location of our image. And third approach is the similarity search, where we take the tags of our image and video and compare them to tags of other images and videos in our database. And then we use the most similar ones to calculate the exact coordinates. The problem with this approach is that it considers all tags similarly important. Even though some tags have geographic information, some don't, this approach takes them all as equal. As of non-visual data, we can also extract audio features from the videos. This area is not fully researched. There are only like 2 or 3 papers about it. And based on the sound, we can get a lot of information. For example, using the ambient sound, we can see if the recording is from some urban or non-urban area, or if it is indoor. Based on the reverberation, we can see how big the room is, or maybe determine the shape of the room. Also, recorded speech can help us because we can determine the language, maybe extract some words, or even dialect from the speech. Another thing that can use to improve our precision is the social network. If we can connect the user who uploaded a photo to his social network profile, we can get a lot of personal information, like upload history, information about his hometown, his friends, and the very interesting thing are status updates and posts, because people usually tend to post where they travel, and that information is very valuable for the location recognition. So as we saw, a lot of these approaches have some flaws, and in the end we can try to combine them in order to get more precise results. And basically there are 2 ways of combining them. One is the hierarchical approach, where we make the priority list of features, and we use only the top list, that is top feature that is available on our priority list. And this is more like having some backup plan. If the top feature is not available, then we use the next one. If not, then we use the next one. But in the end, only one feature determines the location. This is the example that Travis and his colleagues proposed. Depends on if there are tags or no tags. We have different lists. The other approach is the fusion of features. So when all the features that are used in the algorithm are combined for the final answer. I think this is better because each feature has certain information, and this way we're trying to use all the information we have. So in the conclusion, the results show that combining features removes geographical ambiguity, and also combined features always have better results than just one feature alone. And also when combining features, the results show that textual metadata gives us the most information about the location. So for the future work, I think there are 3 directions. There will be further development of the existing algorithms, especially the visual features. I think they really have a great potential, but they're also the most difficult to analyze and to extract information from. Second direction will be combining the features in the right way, because as we saw, when we combine the features, we get better results than just using one feature, but combining them in the right way is probably something that many researchers will try to tackle. And the third direction is towards the large data management, because as I mentioned at the beginning, the amount of multimedia is huge on the internet, and it's getting larger and larger every day, so this is very important. Thank you.